11.4 is all about inscribed angles. Let's talk about what an inscribed angle is. An angle whose vertex is on the edge of the circle. An angle whose vertex, so here's a vertex that's on the edge of the circle, and draw an angle, and there is an inscribed angle. And what it creates is it creates an intercepted arc. And an intercepted arc is an arc that is formed where the two rays of the angle intersect the circle. So here's the two rays that intersect this part of the circle. This is the intercepted arc. There's also another way that an inscribed angle can look. Go ahead and draw another circle. And we're going to put the vertex on the circle again. But one of the rays is going to be secant to the circle. Goes through it. And then the other ray is going to be tangent to the circle. So we have a secant tangent as opposed to two secants as we did here. But a secant tangent, the vertex is still on the circle, and this is the intercepted arc. Okay, so now we know what an intercepted or an inscribed angle is. Let's use it. There's the theorem. The measure of an inscribed angle is 1/2 the measure of the intercepted arc. All right, so the angle is equal to 1/2 the arc. So look here at this first example. They gave us 62. 62 is the angle. So using this, just like this here, we're saying that 62, the angle, is 1/2 whatever the arc is, the intercepted arc. Multiply by 2 and you get 124 degrees is the arc. Now in this case, the arc is arc BW. Now, this is different than the arc length. Notice how this is asking for the measure of the arc. The measure of the arc is measured in degrees for a total of 360 degrees. Arc length, like what we did last week, that's going to have a length measure, centimeters, inches, what have you. This is different. Measure of arcs can be the same in all sorts of different sizes of circles, whereas arc length is from circle to circle. All right, let's go to number 2. Here they want us to find the measure of angle NBC, this guy. So the angle is 1/2 the measure of the arc. In this case, it's 98. So 1/2 of 98 angle NBC is 49 degrees. 49 degrees. All right. Example 3's got some funk on it. Check this out. Angle FBA is 83. So the angle is 83 equals 1/2 the arc. Oops, 83. So that means that the arc is 166 degrees. Now, which arc is that? That is arc here, FA. FA is 166 degrees. Now, let's look at angle ALB. ALB is 130 degrees. So 130 is 1/2 the arc. Thus, the arc is going to be 260 degrees is the arc. Now, what's the name of that arc? This arc is arc all the way to here. Since it is greater than 180 degrees, this is a major arc. So the name of this arc is arc AFB. You need 3 points to name a major arc. Okay, so this green one here is 166. This is 260. So what is the measure? The first thing they want is, what is arc FB? Well, the whole thing is 260 minus 166. FB is 94 degrees. Then the other one is little arc AB, minor arc AB. So here's A, and we're going around here to B. Well, since the major arc of AFB is 260, that means that AB is 100 degrees. All right, let's move on to the next part. It says, if two inscribed angles intercept the same arc, then the two angles are... Let's think about this. Let's look at angle A here. Angle A here goes and intercepts arc BC. Angle A, its rays go and intercept arc BC. Is there another angle that intercepts the same arc? Well, if you follow these rays back, it goes back to angle D. Since they're both inscribed angles, the vertex is on the circle and they intercept the same arc, angle A is congruent to angle D. Angle A is congruent to angle D because they intercept the same intercepted arc. Now, in this picture is also another one. Angle B, here's B, intercepts arc AD. And angle C also does. Thus, angle B is congruent to angle C. Awesome. If an inscribed angle intercepts a semicircle. What is a semicircle? A semicircle is half of a circle. Semi means half of a circle. Then the inscribed angle is a... Well, check out this angle here. It intercepts a right, or 180 degrees, and since the measure of the angle is 1/2 the intercepted arc, if this is a half a circle is 180 degrees, this is a right angle. Why does this have to be true? Just like we said, since this is an inscribed angle and the angle is 1/2 the arc, if that angle goes and intercepts 180 degrees, half of that is 90. All right, page 2. It's got a couple of examples here. Let's do this first one together really quick. X squared minus 54. That's an inscribed angle, and it intercepts. Now, since this goes through the center, this is a diameter. So x squared minus 54, the intercepted arc is a semicircle. So that means that x squared minus 54, the angle, let's write that again, the angle equals 1/2 the arc. Right? So in this case, the angle, x squared minus 54, is equal to 1/2 the arc, 180 degrees. So we got x squared minus 54 equals 90. Now, we only got an x squared here. It's not x squared and x, so we don't really have to factor. We can just get x squared by itself by adding 54, 144. X is plus or minus 12. However, because we're talking about an angle here, can we have a negative value of 12 here? No. So our answer is just going to be straight up 12. Go ahead and pause the tape for right now. Pause this video, and either by yourself or with people around you, give 5, 6, and 7 a shot really quick. Go ahead and pause it, and then we'll come back in a couple minutes and check your answers. All right, so hopefully you had a couple minutes to give these a shot. Angle D here. D is an inscribed. It intersects arc ZL. So 3x plus 30 equals angle E goes intercepts the same arc. So these arcs are equal, or these angles are equal. So we got 5x equals 45. Long story short, you should got x is 9. However, they want us to find what ZL is. ZL is, well, we're not really sure, but we do know since x is 9, this is 27 plus 30. Angle D is 57 degrees. The angle is 1/2 the arc. So ZL is the arc that is in question here. So times 2, ZL is 114 degrees. There's arc ZL. And then we're also supposed to find angle D. Oh, look at that. I already did that. D is 57 degrees. Number 6. Now, look at the whole circle. This is 100. This is 150. That leaves, I believe, 110 here for arc JB. So angle S intercepts arc JB. The angle equals 1/2 the arc. So the angle S is 1/2 of 110. Angle S is 55 degrees. And we're supposed to find the measure of angle JOB. Now, JOB is a central angle, which means that this angle is the same as the arc, is the same measure as the arc. So angle JOB is 110 degrees. Remember, there's a difference between a central angle and an inscribed. All right. Number 7. This 30 degrees is an angle. The angle is 1/2 the arc, which means that the arc is double the angle. So arc AD is 60. Again, with 65, that's the angle. So the arc is double that. So this is 130 degrees. Beyond that, you might get stuck. However, if you look, what else did they give us? Well, since O is the center of the circle, this is a diameter. So if this is 130, this is 50. And if this is 60, this is 120. So what is the measure of arc ABC, the major arc? 120 plus 130 is 250 degrees. Inscribed quadrilateral theorem. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Now, this is confusing a little bit if you remember all the stuff we talked about with parallelograms from the beginning of the semester. Parallelograms, opposite angles are congruent. Here we're saying that opposite angles are supplementary. Again, remember here, the thing to remember here, this is not a parallelogram. The opposite sides are not parallel. So that has nothing to, since this is not a parallelogram, those rules have no apply here. Opposite angle, if it's inscribed inside a circle where all 4 vertices are on the circle, opposite angles are going to be supplementary. So, armed with your vast knowledge of that, go ahead and give number 8 a shot. Go ahead and pause it and see what you got. All right, so hopefully you got 6x plus 20 is, not equal, but plus 3x plus 25 is 180. All right, these two are opposite angles, thus they are supplementary. So 9x plus 45 is 180.